Now, so back to this question again. All right, so this question is the question we have when we first have the this topic. Okay. Now the cost function is this. So this is the function for total cost, and this is function for the price. We want to find the maximum profit. Okay, so if you are doing business, of course, one of the objectives is to find out what is the maximum profit. So how do we know the maximum profit? Right, so this is what we do. Now, first, we are given the price, and we know that the revenue is the quantity times the price. Okay, so we are taking the X, the quantity, multiply the price. So the price, yeah. All right, so expand, we have 15x and 0.002 x squared. Okay. Now for differentiation, we expand so that it's easier to differentiate. So we expand, we get this one. And to find the profit, we know we take revenue minus the cost. So the revenue is this one. So substitute revenue here. And the cost function, of course, from here. All right, so this is the cost function. So we substitute the cost function here. And now we have this. And of course, we simplify. All right, negative 720 here. All right, 15x minus 4x. So 11x. And negative 0.002 x squared minus 0.02 x squared. So we get negative 0.022 x squared. So this is the profit function. All right, now, what is the maximum profit? Okay, what is the production level? All right, that we have maximum profit. So first we differentiate from here. Now, actually, basically this point, this question here is to find the maximum point. Now you imagine the X here is the quantity, and this is the profit. So when we have this function, we can actually sketch the graph. Okay, we can actually sketch the graph like this. We want to find out, all right, what is the maximum profit and what is the production level, this point where we have the maximum profit. So basically this question is about asking the maximum point. So we are finding the maximum point here. Okay, so then we are finding the maximum point. So to find the maximum point, of course, we differentiate the first time. All right, so differentiate here, negative 720 is 0. Differentiate x is 1 times 11, get 11. Differentiate here, we have 2 bring down, so we get 4 here, and the x power 1. So let this be 0 to find the maximum point. Let this one be 0 to find the maximum point. So we have equation equals to 0, and we can find the x is 250. Okay, now we know the production level is 250. But how do we know if this point is the maximum profit or is the minimum profit? How to know it's a maximum or minimum? So
again.
Okay, very good. So we differentiate again. So we differentiate a second time from here. All right, 11 after we differentiate is 0. Differentiate x is 1. So 1 times this, we get negative 0.044, and this is negative value. It shows that the profit is maximum at this production level. All right, so we know that if you want to get the maximum profit, when your production, all right, when your production reach 250 units, you stop the production. Okay, you know, actually many company, they are doing that. All right, so you know, for example, our handphone, after certain times, they do not produce the handphone anymore. Why? Because they have reached the maximum profit production level. Okay, you want to buy, also they do not sell to you because they reach this maximum profit, they will stop the production. Even the phone is very good. Or the phone is, a lot of people want to buy, but they will stop the production. Okay, any questions here, student?
No.
Okay, all right, so if you have no question here, so, okay, now we have another application questions. This is about optimization. So a rectangular has a perimeter of 20 cm. So this rectangular, imagine that it has a perimeter of 20 cm. Now determine the length of the sides. So we want to determine the length of the sides. All right, the sides. When its area is a maximum, so we want to find the maximum area. Okay. All right, so now think of this way. If you want to actually, you have a wrapping paper, all right, and you want to wrap the maximum area of a product, for example, how do you actually cut the side? Okay, so first we need to come up with the function. Okay, for this question, first we ask, what is the function? All right, the function will be the area, right? And also the perimeter. So there are two here, right? Because according to the information provided here, we need to have two. So start with the area. Okay, now the area of a rectangle is length multiply the y, right? So it will be the x times y. Okay. This formula is not provided. You need to know. Okay, it's consider your basic. Okay, now, so from here we have two variable. Okay, now again, when we differentiate, we cannot differentiate two variable here. We cannot differentiate x and y at the same time. No. Okay, we have two variable x and y. So we cannot differentiate two variables at the same time. We need to change this to one only. All right, so change to one variable. Okay, so this one you have to take note. When we have two variables, you have to change to one. How to change to one variable? Then we need another formula here, the perimeter. How to find the perimeter? It will be 2x, sorry, this is the y. 2x plus 2y, right? So 2x plus 2y. And the perimeter is 20. So simplified here, we get x plus y is 10. Okay, now you can actually replace the x with y or replace the y with x. It's up to you. Now, if we want to replace the y here, so we bring over the x. The y is 10 minus x, so we are going to replace here. Okay, the y is 10 minus x, replace the y with the x. So replace here, now you can see we have only one variable, which is the x. So this one, 10x. when we expand here, we have x squared, and this is the a, one variable only now. So then from here, only we can differentiate. So when we differentiate, we have 10x. Differentiate is 10. And differentiate here, we get 2x. Okay. So after that, let the dA dx be 0. All right. And we want to find the maximum point. Okay, we want to find the maximum point. So 10 minus 2x is 0, and we can get the x is 5. Substitute this one into the y, and we know the y is also 5. Okay, now how do I know this is a maximum? We differentiate again. So when we differentiate again from here, we get -2. It's negative value. Therefore, it is the maximum. Okay. So do you have any questions here? Any questions, students?
No. No.
Oh,
No, sir.
Okay, thank you. Now, I actually update the differentiation ebook. If you, okay, these are the books that, the chapters that it can help you to know more. So you can actually read, all right, so the differentiation rule. Okay, they are all here. Okay. And of course, if you want to have more challenging questions, you can actually get from here. Okay, so all these are optimization problem. How to find the maximum or minimum. Okay, so some of them are quite interesting. Okay, so you can see here, right, example for economics. Okay, the cost, revenue function, cost function, profit function, and all that. Okay, so some of these are quite challenging. You can actually try the questions. All right. So I think we stop here for today. Actually, we have one more example. All right, but you can actually try this one. And we have a tutorial question is actually similar to this. Okay, so we stop our discussion here today.